Good morning, good afternoon, and good evening, everybody. This is Gabriele speaking from Moviri, and welcome and thanks for joining this webinar about network capacity planning. As most of the US team of Moviri is located in Boston, we want to make it personal and offer you some real scene. So that's why the slide you've been seeing for the past few seconds. And today's webinar will feature our partner Entuity, and this is going to be the agenda for today's webinar. I'll introduce the speaker for today. We will talk about what network capacity planning is. We will showcase how BMC through site capacity optimization can help addressing network capacity planning topic. We'll then have Entuity explain how the solution can further enhance capabilities of through-site capacity optimization. Finally, we will wrap up with takeaways for this webinar. You will also have the chance to see what are the next events planned for upcoming months, and some time for question and answer. By the way, I encourage everybody to post their question in the question area so that we can address them at the end. So, speaker for today, from Moviri, we have Renato Bonomini, Director of Business Development. His background is in digital signal processing and high-performance computing. He is an expert in architecture and design of capacity management and related process, and you can also see his email and social reference. From Entuity, we have John Diamond, also known as JD, Product Manager at Entuity, responsible for understanding customer needs, guides future development of the product, and participate in product evangelism. Having that said, I leave to you, Renato, to go through the topics for this webinar.
Great. Thank you, Gabriele. Well, thank you, everyone, and thank you for joining today. I realize your time is important, so I'll try to get quickly to the point. And the reason why Moviri today is here with you trying to speak about network capacity planning is that we have a lot of organizations in designing, implementing, running what I hope they are successful network capacity planning initiatives. In particular, most of our long-standing customers are indeed telco companies. And let me guide you through some of the things that we learned by going through this process. And indeed, sometimes there is really no better way to learn than to understand what you might not be doing right. So let's take a look, for example, at a few of activities that I would define as being, well, really not such a great idea. For example, confusing the role of network monitoring with capacity planning. That's really never a starting and a good idea. Or another example, rely too much on events monitoring. Well, you need to understand the trends, the pattern, not just the exceptions, not the fact that a device is above a certain threshold. Another thing that you probably should not be doing, and take a look at what you are doing. No harm intended to people that are doing it, but just understanding how to improve. Forget that you're looking at just servers. You're looking at devices. Try to understand what is the right approach for network capacity planning. These things are different than a standard server, so how does the approach change? And the approach change, and we'll take a look later on understanding better what's specific to those devices. Another one of those activities which really happens frequently, and I see a lot of companies struggling with, is indeed spending so much time collecting the data, cleaning the data, and then not using that data which is available. So wasting a lot of time collecting valuable information, but then at the end of the day, that information is not actually transformed into actionable intelligence. So let me try to put on again my nerdy background as an engineer, and here's where it comes out once again, and suggest a high-level framework which is simple enough, and then we'll go into details on how to make it actually effective into your organization. So First step is frame the problem. So what is really my network? And there is a good analogy that I've read on a document which says that your network is your IT as your nervous system is to assist to a human body. So that's a good analogy that can help you actually understand what your network is. So that's something that you need to find out up front. Frame your problem. The second one is identify what are you trying to achieve with capacity plan. Now, stop a second and try also, before we go any further, to identify in your organization, are you trying to do risk mitigation, or are you trying to do cost control? Or you're trying actually to achieve both at the same time. So it's important to understand what is the goal of the specific activity that you are performing. Is it one, the other? Is it both? That's important because it will guide us in understanding the use cases. Next steps will be identify the players, so what the components actually are. It's nice to talk about high level of stuff and frame the problem, identify goals, but we really need to come down and get things done. So let's start talking about load balancers, routers, switches, network links. Let's get down to the details. And once those are mastered, also be able to adapt that. One approach might not be the best one for every single opportunity. So if things change around, it's important to understand how you need to adapt. And in particular, it is really important to understand that the bottlenecks that exist in your environment are there now for a reason. You work towards changing the bottleneck, migrating it somewhere else, moving it away, but you never actually take away a bottleneck. You simply migrate it somewhere else. You cannot eliminate it. So that's important to understand that these approaches work in general as a starting point. But the more you improve your process, the more you improve your environment, the more you need to be able to adapt. All right, so that's hopefully enough information at a high level. Let's go now a little bit into details. And by the way, we'll have a possibility of doing some Q&A at the end. So if you have any question or anything else, please feel free to put it in the chat window or in the questions panel, and then we'll start addressing them at the end. So we mentioned a second ago, first of all, frame the problem. Let's draw a diagram of our network infrastructure. This is a very much simplified one, and understand what are we looking at. So let's look at some of the components that are in our network. And we look at access level, core level, edge. We see that there are network devices. We see that there are links. We see that there are links which are local, links which are between data centers, between the outside world. And when it comes down to try to define the scope, that's the first step, define the scope of network capacity management. Let's try to limit that scope for now. It's a very good starting point to devices, so routers, switches, firewall, load balancers. That's one area. And links, intra-location LAN, inter-location WAN. So if you start from this understanding, there are just a few objects, and we're going to look at those objects and understand how to manage those specific objects. Now, another aspect. If you look at the amount of traffic, and this is something that I heard frequently, so this also belongs to the area of DONT. I hear a lot of organizations say, hey, if I look at the amount of traffic within our data center, it's the biggest one. And indeed, out of interesting standard numbers that you can find, and there's a reference down at the bottom, you can see that most of the traffic within your environment is indeed within a data center itself. So, for example, 76% of the traffic is within the data center, the yellow traffic. There's some traffic between data centers and also some traffic on the outside. But don't be tempted into thinking that, oh, I just need to focus on the traffic within the data center. Well, consider also, as we were mentioning a few minutes ago, consider also what is the limiting factor from your perspective. So are you paying for that bandwidth, or is that something that actually you're not paying for? So within your data center, you probably have a lot of bandwidth available, so you can actually think that that's not going to be a limiting factor. But if you look at the outside world, the network towards the outside, you are probably paying someone for that connectivity, so you should really care after how much you're using and take a really good control of how much traffic you're going outside. So Just don't look at these numbers and be tempted into thinking, I just need to focus on my local area network. Actually, local area network most of the time is less important than the outside area network because you have more control within your data center than how much control you have with the outside world. So that's important to be considered. Now let's focus on those devices that I highlighted there. And what I would like to do is try to write a map. And by the way, for this webinar, this is the very first time that we put down this map on paper. So I spent the last few days trying to put this down, and I hope I've done a good job, and please let me know if that's not the case. In terms of giving you some very simple guidelines of what to do, in what occasion, and how. I know it might be a simplified way, but if you're starting, and if you want to have guidelines, this is an excellent perspective. Well, I created it, so I hope it is excellent. Let me know if that's not the case, and let me move forward. So those are the devices we just talked about. Switches, load balancers, firewalls, routers, and links in general. Anything which can be a physical link, virtual link, MPLS link, anything which brings data from one point to another. And we can see that the scope smoothly changes from LAN, local area network, to one area network. So those are usually network terms that are accepted into the network world, but very often the capacity planner doesn't see what's the difference between LAN and WAN from a capacity planning perspective. There is a slight difference in how we handle them. So the first thing that we can take a look at, as I was mentioning a few minutes ago, is understand your environment, understand what your limiting factors are. And if we look at those, we can see that there are clearly different bottlenecks or limiting factors in those devices, in those entities. If we look at switches, very often the limiting factor is the number of ports. We are in the local area network. You have a high-end switch for your department, for your floor, for your data center, for your rack. You probably have 32, 64, 128 ports. Those are probably 10 gigabits port. Are you really going to saturate 10 gigabit port out of 128 ports? That's unlikely to happen. So that's why we probably most likely focus on the number of ports. And when I say when you're dealing with 100,000 network devices, well, you don't really have the luxury of everything that you can do on every single entity, which comes down to this simplified version of, okay, you're looking at switches, you might expect that the limiting factor is the number of ports. There might be exceptions, like, for example, the uplink port of a switch might be important, but in general, number of ports is what you're after. You want to make sure that there are enough ports available for you. If we move it to other local area network devices, in particular the ones that are resolving you to access the external world, load balancers, firewalls, routers, you might be tempted into thinking that the limiting factor there is actually the network traffic they can handle, the bandwidth. Most of the time, those devices are actually, nowadays, when we're in a world where we talk about software-defined networking, most of those are really traditional servers. Some of them are specific devices which have been created just to do that. But for example, load balancers, there are a lot of vendors right now which are just generic purpose servers which have load balancer software on them. Firewalls, routers. So at that point, they become more of a service, more of a traditional capacity planning for people that come from capacity planners of compute. So we look at CPU, memory, and something which is unique to network devices, which is backplane utilization. That's important. You might have as much CPU as you want, but if you're not able to transfer data from one card to another, backplane is important. So we move to those entities, and the limiting factors become different ones. It's only when we go to network links that at that point bandwidth becomes important. And by link, I mean anything which is a critical path where traffic is merging and migrating from one area of your environment to another. It might be from one data center to another data center. It might be from your data center to the outside world. But all of the traffic is merging and going probably on a single pipe, whether it's physical or virtual. It's actually a fiber optic, or it is actually just a virtual link. You treat that as a link, and all the traffic is converged and going into that link. It's like a highway. That's how we put up at the beginning the image of Star Drive, which, by the way, I ride to work most mornings, and believe me, traffic can be really bad. So if you can imagine all those cars being your IP packets in your environment, and how would you feel if your IP packets were you driving, start drive at 5 p.m. rush hour? It's really going to be bad. You know you're going to be stuck in traffic. So it's really important to make sure that those links are managed properly. But at that point, the limiting factor on, for example, a high-end router which handles several links, you want to handle the router itself as a server, but you also want to handle the links. Because the links, for example, a single interface, it's at that point the critical aspect, because you might have one link that goes from a high-end routers to the outside world, and the connectivity for that specific link is what you're probably paying someone else for. So that becomes the limiting factor. Which moves us to the next section about what are we trying to do with this device? Okay, we're doing capacity planning. Well, what does capacity planning mean? And in particular, let's try to come down to a few ideas of what capacity planning can actually mean. And in this case, it could be the first one. Okay, I have switches. When am I going to run out ports? If I need to put in a new host or a new physical server, well, if there are not enough network ports, that's going to be a problem. It's very hard to fit yet another patch cable into a switch which is full. Oh, just get another switch. Okay, we procure it, we buy, we put in place, power, rack. So it becomes a problem of proper planning. So that's really proper capacity planning. That's a very common exercise for switches. When we move to the other class of devices, and you can see here there are really three clusters, load balancers, file and routers, we handle them as if they were traditional capacity planning for compute. Do we have enough computational capacity? A load balancer, for example, might have 10 gigabit ports. You're not going to have, well, I actually suggest that, well, I hope for you that you might have 10 gigabytes of traffic out of end users on your e-commerce website, but that's unlikely to happen that you have 10 gigabit traffic. So you're not probably going to saturate the physical ports. You're not probably going to saturate the bandwidth. The ports are static, they're not going to change, so that's not a limiting factor, but the limiting factor is probably the computational capability of that specific network device to handle your workload. And your workload is IP packets, sessions. It can be web hits if it's a load balancer. So it can be anything which is the actual workload, so it becomes a more traditional exercise for the capacity planner. When we go to links, the question is how much traffic can I push on this link? I look at my peak periods, I understand my trend. There are some techniques which are, I define basic, and some other ones which are defined advanced that comes into place. And now, so far, I like to achieve from it to some ideas of use case. Let's go down to how we actually do it. So basic techniques are things that when we look in particular at the solution that BMC has put on the market, and which is called true-set capacity optimization, for which Moviri partners with BMC in terms of extending functionalities, and in particular what we partner with BMC in extending functionalities when it comes to network. That's why you will see the Moviri brand very often associated with network when it comes to true-set capacity optimization. The ones that I'm put down as basic techniques are available with built-in reporting. Cases, ports forecast, devices overview, interfaces utilization, interfaces forecast, those are available right away. So you don't have to build anything, you don't have to create reports, you don't have to create your own analysis, they are there, they're just available. The advanced techniques are more for the power capacity planner. Indeed, let me show you a few examples. I will guide you through a few minutes into showing you the built-in dashboards that are available. But some of the examples in terms of advanced techniques, I'm not going to be able today to spend a lot of time on showing you how to do it, but I will give you some pointers, and maybe we can organize something as a follow-up. Are, for example, correlation analysis, where we understand in this specific example, how much more activity can I put on a load balancer? How much additional users can I put on my application until my load balancer saturates? Or in this other example is, I have different classes of users. I know how many users of each kind are connected to my application, and I'm looking at the network link which sits outside of my data center, and I'm doing what's called multivariate analysis to understand what's the impact of one type of customer versus another. What if I change the mix of these customers? How much bandwidth do I need as an aggregate? So what we're doing is we're understanding out of a single link bandwidth how much the contribution of different type of users using my application are weighting on the network link itself. So how can we effectively support this process by indeed using true site capacity optimization? Let me show you. Okay, now. Okay. Let me log in as a regular user. Okay, and I need obviously to log in again, so. All right. Okay, I'm going to the views section. This is where you can find the built-in reporting with these are called dashboards. And I'm going to open the Moviri network view. As I mentioned, Moviri is for BMC Software, a provider of extensions. And in this case, I'm showing you what we provide from Moviri as an extension to the network capabilities that true site capacity optimization has. And as you can see here, you have 4 tabs, which are significantly showing you what's available in terms of use cases. So let me go quickly through them. So in this devices overview, you simply point to a domain within your environment. So in this case, I'm looking at a hypothetical Moviri network, and I'm trying to understand what's happening in my environment from an overview perspective. So I see the list of devices. I can understand which ones, for example, have a daily peak average. That's a very common KPI for studying networks, the highest one. So this device right here, it sounds like it's having a little bit of a tough problem from a network perspective. So the average peak of the day is about 46%. It's still good. There are really no signs of undercapacity in this environment. But if I look at the second one, I see that the backplane utilization over the period of time, this is last 30 days, it's been 95%. So as a general practice of most of these built-in capacity optimization views, you can drill down and see what the details of that specific device and see what its configuration is, some of the values, and you can even drill down further and take a look at specific interfaces if the data is available. Like for example, in this case, I can see, well, not every single interface is actually highly utilized, but that's the network interface that I really want to take a look at, and I can inspect what's happening in that interface. So here I'm simply looking at what's happening. If we move the time frame from up until now to the future, I can actually see the use forecast being useful. My network in this case is behaving pretty well because I have a series of devices which are at capacity in terms of how many ports, and the other ones are pretty stable. So it's a very stable environment. But as you can see here, we have a column which days to crash in a very theoretical form. This has been around for a while, and I like the people like, hey, things are going to crash, so you need to make sure that you take an action. And what we have here is an indicator that will tell you, you know, in about a certain amount of days, you are going to need to add an additional device because there are going to be no longer ports available. And you can see the number of ports and the number of currently used ports. So that, for example, you need to provision, and you want to say, as in common in every single page here, is that, for example, you want to focus only on access. Well, then you can simply select access devices. And I need to provision a new, I need to plug in a machine. Which one is the machine that has the least number of ports used? Or, for example, the one that has the highest number of ports. And I can drill down and see the information. So this is really meant to give you a way to understand how many ports you're going to have in the future. If we switch the point of view to interfaces, so the links perspective, we have a similar page that allows you to study what's happening in your environment, and it also gives you an idea of the distribution of information. So how many links of that specific device are between a certain usage, so we understand the distribution. Or we can also take a look at the forecast so that we can say, okay, I want to know when I'm going to run out of capacity on that specific link. So we are shifting the point of attention from being the device to be the actual link. Now, let me go back to my slide set. And let me show you some of the more advanced use cases. For example, advanced forecast. So what we do, you collect data about several interfaces. We create a link which can be a logic link, a physical link. We study all of the KPIs, so the daily minimum, average, maximum, percentile, and we put a bandwidth capacity in place. So these are all things that are common in the compute area. But you can recognize that some of the forecast algorithms that are available within capacity optimization are indeed specifically designed for network capacity planning. Like if you take a look at this one, which is the linear yearly time shift, this is meant to show you how a very seasonal network link usage is going to perform in the future, and it has the pattern of the waveform and the minimum and maximum across time. Also some other ones which are come really handy when you're doing forecasting of link utilization. Another advanced use case is, for example, estimate the residual capacity using business data. So you have a set of links, you have a set of users. What you do, you understand the relationship between the amount of users and the bandwidth. You compute the demand. You take that demand and you say, hey, I want to support more users. How much additional bandwidth do I need? And at that point, you take a marketing plan and you set a goal. For those of you familiar with business and line capacity management, this is really not different than business and line capacity management. And that's the reason why I would like to point you to a tutorial that we had back at CMG 2015. If you can find it, let me know, I'll send you a copy, which is business and line capacity management with true-side capacity optimization, which is not strictly about network, so the technique is actually generic, but it very much aligns to what you can do within network. And last topic that I'm going to mention is, okay, to support all of these use cases, we need data, right? How can we actually make the data available? First of all, collect the right amount of data. Do we collect 1 minute, 5 minutes, 15 minutes, hourly data? Well, it's a good example of your mileage may vary. So really depends. If you have no clue and if you don't have time to test, what you can do is take our suggestion, which is, well, if you have no idea where to start from, start using hourly data with statistics, like minimum, average, maximum, percentiles, and see if that's sufficient, if it gives you enough information about how your environment is changing. It depends really on how the people using your services are behaving. So it might really vary, but it's important. Another question is, do I need all metrics for all devices? Well, we just saw that if you look at the switch, all you care about is the number of ports, whether those ports are used, 0, or not used, actually 1 or 0. So you don't really need how much bandwidth is being used on a single interface. So you probably should look at what data is important for every type of those 3 types of entities that we identified. So if we transform these ideas into functionalities, for example, import aggregated statistics, that's important when import data. The ability to filter by device type. A lot of data sources are available as SNMP polling data sources. And I've seen a lot of companies pulling in printers and generic devices. Do you really need a printer within a network capacity planning initiative? Probably not. So you probably do not want to import that. You also want to import metrics according to the device type and also replicate the structure of the data source. If you are organizing objects within your data source, as usually we collect information for capacity optimization, you might want to replicate that structure. Why throw that away? For people that are familiar, this is the object relationship concept. And it has to be scalable, which leads me to show you some of the integrations that are available. And some of these integrations are the officially supported one, and Entuity is one of them. And this one that we recommend, in particular if you're looking at the scalability. For example, one of our largest customers, Sanofi, has the Entuity for data collection and monitoring of network devices, and we collect data out of Entuity to perform capacity planning within capacity optimization. We also have HP and NMI, those are built-in integrations. And then we have a set of additional add-on packages, which you can find in the marketplace. And that's a place where you can find and you can see additional integrations which are not part of the standard package. And if you'd like to know more information on that, please let me know and we'll get you some more information. At this point, I would like to pass the ball to JD. And JD, you can now control.
Okay, well, thank you very much, Renato. I've been looking forward to filling in the gap that Renato has just been talking about here, which is how to obtain this data. And as you've just heard, there are some complexities involved in gathering and structuring the data, which you can cut through almost entirely using Entuity in its default mode of deployment. So what is Entuity? It is an enterprise-class network management solution, and by that we mean that it is highly scalable, it is highly distributed, it has a federated architecture that means it can scale out to handle from very small to very large infrastructures that may be located in a single location, but also may be scaled out geographically, possibly even globally. It fits in with other enterprise-class systems such as BMC's range of BSM products, particularly the true site capacity optimization that Renato has just been talking about, but also true site operations management and various other of their enterprise-style management products in a highly integrated, off-the-shelf integration approach. And as you can see here, the network management topics that are cover all the way through from discovery and inventory management, which is fundamental techniques that you have to have in place in order to perform network management, but also topology discovery, where all of the linkages between devices and ports are automatically discovered, automatic real-time event generation based on anomalies, configuration monitoring and configuration management capabilities, performance monitoring, and that comes in particularly important because we're gathering those performance metrics, the utilization metrics and data flow metrics that are needed in the integration to the true site capacity optimization product. We've also got additional capabilities such as NetFlow and various other flow technology support for giving a much more detailed insight into the nature of the traffic and what it's being used for, and other techniques such as root cause analysis, which is used to reduce the event flow. Also, this being a very fully featured product, there are reports and dashboards all built into the product. There are an enormous number of pre-built reports and dashboards, as well as a report and dashboard building capability. You've got the integrations to many products, including those that we've just been talking about. And we handle both the virtual and physical world. These days, many network concepts are being moved from physical servers into virtual servers. A lot of that already happened, but you've also got networking components now moving from the physical world to the virtual world. So you have virtual switches built into your virtual servers. It is heavily, heavily automated with appropriate automation to make the management of a very complex system highly achievable and practical in the real world. A system that needs minute-by-minute babysitting just isn't going to be a success in the real world. And it is highly scalable and heterogeneous. We handle many, many different vendors' equipment. So the relationship we have with both Moviri and BMC, we, as in the case of Moviri, we are both market zone or technology alliance partners of BMC. In the case of Entuity, we've been a market zone partner with BMC for over 7 years, and we've got over 260 joint customers around the world using combinations of BMC and Entuity products. And high among those products is the true site capacity optimization, which is the focus of what we're talking about today. So how does some of that integration look like? Well, with Entuity in the heart of this diagram, we've got linkages out into many of the core components offered by BMC, including their true site operations management and down to Atrium as well, with ITSM modules in the middle there. But also we include the network automation product, and particularly, as it's the focus of today's discussions, the true site capacity optimization, where we provide performance and a variety of other metrics, including those port usage and which ports are used and which ones are not, that information out to true site capacity optimization in a highly automated manner, which allows us to practically take advantage of it. So the business impact of using network information in a highly integrated way with the other tools, where you're not just looking at the network management information, but you're looking beyond, in that that is a part of a bigger IT story. We've got benefits going to various different departments within the organization, being able to take into account not only what the applications are doing, what the servers are doing, what the middleware, the storage, and all of those other parts are performing in real time, but also how it's all linked together. Without that nervous system, as Renato mentioned right up at the beginning of the presentation, the data flow between these different parts of the system will grind to a halt. That needs to be monitored. So we've got various factors that really need to be taken into account when you're looking for an enterprise-style network management system. So rather than just any network management system, one that you might install in a small to medium-sized company or some other organization where the network isn't particularly large, not particularly demanding, when you're dealing with enterprise-style scalability, then you've got some big considerations. Fundamentally, the architecture needs to be put together in a way from day one that it is intended to facilitate that level of deployment. And with Entuity's architecture, I mentioned you've got a federated approach. It can be deployed on one or multiple servers that perform in a parallel style processing operation, where they are each managing different portions of the network, but then allowing the information to be gathered centrally on an as-needed basis. It's a sort of just-in-time architecture where data is moved when it is needed, rather than gratuitously moving enormous amounts of raw data into one central database, which of course then becomes the overall bottleneck. So we have a consolidation approach whereby you would have a server that would act as a reporting and user interface consolidation central point, and that gathers information as and when needed from the multiple remote servers that are actually performing the real network management, looking for the anomalies, generating the events and incidents, and sending those out to the different parts of the integrated environment. Automation is the heart, not only automatic discovery of the network, but networks change. That's a fundamental factor that you have to take into account with a modern network. It is continually changing. Not only are humans making the changes, but now increasingly those changes are automated, and they have to be taken into account by the network management system if it's going to stand a hope of actually providing useful information. The ease of use is critical to actually achieving a practical result. If your network management system needs an army of engineers to just keep it running, then that is not going to be practical. And also, if the information is not readily available and the system is not intuitive to use, then again, you're not going to have a successful outcome. That is a consideration at the heart of our design philosophy. And we live in a heterogeneous world, so not only do we have a multitude of different vendors providing equipment for the network, different routers and switches and load balancers, you might consider that you have picked a single vendor. Let's take, for example, Cisco. You might say, I have a Cisco network, but are all of your load balancers and firewalls and other parts of the network all currently or in the future always going to be from that same vendor? We work on the basis that you have to be able to support multiple vendors simultaneously in order to achieve the results. And we can support our software on multiple platforms, again, either physical or virtual, and that's ranging through Windows and Linux servers, and they can be either physically hosted or virtual servers. So really, that's the type of consideration that you must give in order to get a successful enterprise-style deployment. And just to wrap that up, you've got a number of benefits that can be taken from an integration where you're taking network monitoring information and incorporating that in real time with other disciplines. And not only is that consolidating event-style information from the events generated from server and application and storage monitoring, but also when you're taking data that's been gathered, data points, metrics, and intelligently processing them and deriving information. That's the heart of the capacity optimization product, where it will take the information that's been gathered on relating to things like port utilization, like spare port analysis, and deriving real business value from that information for the different parts of the organization. So we believe, and we've got documented evidence, that there are many different ways that not only adopting our technology for your network management purposes, but then further integrating it into the wider environment, including capacity optimization, gives many advantages in different dimensions. And finally, just a note on some comments that we've had in from an analyst up at the top there, that is talking about the benefits of this type of approach on the real-time reliability of the network, but also then one of our large customers about the success that they've had in deploying our technology for their benefit. So with that, I'll pass you back to Renato.
Thank you, JD. Always fascinating hearing JD speaking. I hope you appreciate it, and thank you, JD, for making yourself available. Let me summarize 3 important takeaways. I know we talk a lot about things, high level, down details, lots of things, and 45 minutes are never enough, so we are right about the end. So let me summarize quickly. 3 things that I would really like you to take away from today. The first one is wider network, local network devices. Look at them as being network capacity planning. Each one of them requires a specific technique. So look at them differently, understand what the bottleneck is. So that's the second one. Each one of them can be handled the same way, but you really need to understand what the bottleneck is in your specific moment, in your environment, and how your users behave. There are not that many bottlenecks. That's a good news. Just identify the ones you're working with. And the third takeaway is, when possible, align IT to business. Don't look at your infrastructure as if it were just a highway with a bunch of cars. Think that people are going on vacation. So you know how many people are going on vacation, likely year from year. So you can actually plan how many lanes you need on a highway. This is not rocket science. It's been available for a while. So if we translate them into IT to business, that's possible. Now, for the next events, Gabriele.
Well, first, thanks to Renato and JD for this session. Very informative, lots of information. Hope you enjoyed it. And as for next event, we will have Moviri on September 15. The topic will be the convergent infrastructure capacity management. It's capacity management applied to convergent infrastructure. Then, if you want, we may meet at BMC Engage, running September 6 to September 9. And if you want to engage with either Moviri or Entuity directly at Engage, look at the chat where I will post the contacts to ask for a meeting there. Now, if you want to spend another couple of minutes with us, there are a couple of questions coming from the question area. The first one is for Renato, and the question is about the views that you showed during the demo. The question is, are these views capable of being generated using SolarWinds data?
Good question. Most of it, I would say that SolarWinds data can be made. It's one of the integrations that we listed. We've done it a few times. Most information is available. There was some information which is not, is for example structured, additional metadata which we use to categorize, like the type of device, the role of device. That kind of data it's usually missing while we have it, for example, from Untitled. So some of it is available, the raw numbers are available, so there's partial functionality available, most of it displays.
All right, thanks very much. And there is also a question for JD. Question is, do we need to be concerned with additional capacity overhead if we integrate Entuity with two-side capacity optimization?
Okay, that's a good one. In fact, it was one of the topics that Renato and I discussed in detail in the early days of putting the integration together. The technique that was decided upon was using what Entuity called data export, which is a way of taking subsets of data, and so we choose exactly which data we're interested in and need to export, and have that scheduled to be exported to a secondary data set within the database server. This means that when you're moving that data across out into the capacity optimization product, there is very little overhead because it's been exported in the most optimized way. So the answer is no, you don't need to be concerned. We've taken that all into account in the architecture of the integration.
Thanks very much, JD. There are new questions coming up. Let me read it out. I would say this is for JD as well. Does Entuity have an SNMP poller to gather the network metrics? And there is a second question attached. Does it handle quality of service metrics?
Could you just repeat that last part of the question, please?
Okay, I repeat everything. Does Entuity have an SNMP poller to gather the network metrics? And does it handle quality of service metrics?
Right, okay. SNMP is probably the most important way that we gather data. Not only do we gather the metrics from the network, but we also discover what the devices are, what they comprise, how they're configured. That's all performed through SNMP. It's the main technique used. Not the only technique, we've got others, but SNMP is very important in what we do. We support SNMP v1, v2c, and v3. So you've got all bases covered there. We can even talk over IPv6 if necessary to devices to get that information. When it comes to quality of service, then we've also got the ability to discover, particularly in the world of Cisco, the quality of service configurations that you've got on devices. what can be very complex structures of configuration relating to quality of service and all of the different mechanisms used within that. They're all instrumented. We automatically discover that. We discover how it's configured, and we automatically then pull the most appropriate metrics from it as well. So once you've got that mode enabled, then it just does it automatically. And so we've got that information available. Not only can we generate events in real time on threshold crossing from aspects of quality of service monitoring, such as discarding excessive amounts of one class of traffic in real time, but also the data is being stored and can be exported if necessary.
Thanks very much, JD. Very last question, and then we'll be over. For Renato, in your experience, what do you think is the greatest advantage / result for integrating Entuity into TSCO?
Oh, good question. And actually, JD already mentioned that the mechanism of the integration really allows for offloading of the old components between the integration, like from the Entuity down to the database, down to the export, down to importing into capacity utilization. The way that it has been designed allows for a very scalable process, which in large environments has been a significant issue with other solutions. So I think that's the biggest one. And the partnership we have in Entuity allows us to put these practices in place with a partnership. It's not that, hey, we have an integration to build and we scrap documentation on how to do it. It's been very successful, so that I think it's the biggest advantage.
Well, again, thanks very much to our speaker, Renato and JD, and thanks you all for joining this webinar. I remember September 15, the next one, Convergent Infrastructure Capacity Management, and have a good day.
Thank you, everyone.